Okay, this is the last part of our chapter. We are going to talk about metals and non-metals now. We saw that the metals are in the lower left part of the periodic table. The non-metals are in the upper right part. We are going to see which are the differences between the properties of metals and non-metals in this last part of the chapter 3. In this first slide, we can see some pictures of nickel, mercury, gold, and copper. Nickel is located in the center of the periodic table. It's considered a transition metal, the same as copper. Then we have silver, that we don't have a picture, but we have a picture of gold, which is AU, and Hg, which is mercury, is the only liquid metal in the periodic table. You can see that the letters are in blue. Now, most of the time we don't use pure substances unless they are specifically necessary. Like, for example, the copper in the wires, the more pure the copper is, the better is going to be the conductivity. But in general, we use alloys instead of that. Alloys are solid solutions, so they are mixtures, homogeneous mixtures of 2 or more metals. Like in here you have the bullets that are going to be 98% lead and antimony and silver, nickel, cobalt, and other metals mixed together. Now, when we talk about metals, what are metals? Well, metallic character describes the properties that a substance has to have in order to be considered a metal. We are going to see the different physical and chemical properties, but basically, if you go from top right on the periodic table to left and bottom of the periodic table, we are going to see more metallic characteristics or metallic character. This metallic character is associated with the ability of the elements to lose electrons. So that's why metals most of the time form positive ions. That means that they are going to lose electrons in the process of combining with another elements. This is a set of slides that we are going to see different properties of the metals that are characteristics of them. For example, metals have luster, and luster means that they are shiny. We also know that metals are malleable, and malleable means that we can hammer them into different substances like this one, also into sheets. Metals are also ductile, and ductile is the property of pulling them down into wires. And you can see here copper wire, and this is a nickel wire. Most of the metals have high melting points, and when I say most of the metals, because the metals that are in the far left of the periodic table, the group 1, are going to have low melting points. But in general, since the majority of the elements have high melting points, especially the transition metals, we can use them as pans, for example. We put it on the fire and they are not going to get molten or melted. Also, when we see in general they have high density, that means that they are going to sink in water, for example, like the coins. Now, if you see, again, group 1 is an exception to these rules or to these properties, because lithium, sodium, and potassium not only are going to float in water, but also they will react with it, and we are going to see that later. The metals are also good conductors of electricity. That's why we use it in wires to conduct the electricity, or in circuits to form batteries or so. They are good conductors of heat as well. That's why we can use them in stoves. And when we have to handle something that is hot, we are going to use something that is non-metallic, because if not, we can get burned. The heat is going to flow from the hot surface to the cold surface, moving the electrons, and we are going to see that when we see metallic bonding in the next chapter. The metals in general, we said that they rust. Actually, rust is a term that we use only for iron, and you associate rust with this reddish color that we have here in the picture. In general, we say that the metals are going to react with oxygen and water in the air to corrode, and corrosion means that they are going to react to form different compounds. Like a penny, for example, here you can see that it's going to get into different colors depending on the level of corrosion. Another example of corrosion is the Statue of Liberty. The difference between the rust and the compound that covers the Statue of Liberty is that the rust is going to crumble apart, and they are going to eventually break down the metal and disappear eventually in the earth. In the case of the Statue of Liberty, the copper carbonate, that is the substance that covers the Statue of Liberty, does not dissolve in water, and that does mean that it's going to stick to the surface, protecting the inner levels of, or the inner layers of copper. The metals are also sonorous, and that's why we use them in bells or some things like that. And that is the ringing that stays after you hit it with some surface. We said that the metallic character is going to be the ability of losing electrons. Most of the metals lose 3 or less electrons. They have 3 or less electrons in the outer shell. That's why they are going to form +1, +2, or +3 ions, and we saw that in the prior PowerPoint presentations for this chapter. Most of the metals react with acids to produce hydrogen gas. This is in general. Okay, so for example, zinc reacts with hydrochloric acid and is going to liberate, and you can see the bubbles here of hydrogen gas that is produced. There is a test for hydrogen gas that we can do. If we put a wooden splint that has been lighted, we can see that it's going to pop, and that is one of the demos that I'm going to do when we cover transition group 1 metals. Some of the metals are so reactive that they are not going to react only with acids, but also they are going to react with water to produce also hydrogen gas. For example, group 1, and here you have lithium, sodium, and potassium. You can see that the reactions are going to be more vigorous because the potassium, since it's in the lower part of the periodic table, is going to have more metallic character. That means it's going to react easier. Some of the metals, the ones that are less reactive, they are not going to produce hydrogen gas. Actually, if you put copper inside chlorhydric acid or hydrochloric acid, it will not react. It will not react also with water. We need a stronger acid because the copper, the same as the silver, for example, they are more stable, let's say, and they are not going to react with certain acids. We need something strong like nitric acid in order to produce that reaction. And you can see that the gas that is liberated is not hydrogen gas, is this brown gas that we call nitrogen dioxide. That is a brown gas that is poisonous. So that's why if you do this reaction, you should do it under a fume hood. We saw the properties of the metals. Now we are going to see the properties of the non-metals. The non-metals are on the top right of the periodic table, and you're going to see that even they look different. Here you have carbon, sulfur, which is a solid yellow, bromine, that is the only liquid non-metal in the periodic table, chlorine, which is a green gas, very pale green gas, and phosphorus. This is one of the allotropic forms of phosphorus. We have two, red phosphorus and white phosphorus, but the red phosphorus is actually red. The difference, one of the main differences is that the nonmetals are not shiny. They are dull or opaque. And here you have the different forms of carbon. Here you have charcoal. Okay, you have also graphite that you use every single time that you use your pencil, because the pencil is made of graphite. And in here you have another form of carbon that is produced under a lot of pressure and heat, and that is called diamond. In here you have also the sulfur element, and you can see that both of them are dull or opaque. They are also brittle. That means that they are not malleable or they are not ductile. And if we hammer them, instead of having a sheet like the metals, we are going to have breaking down the structures in smaller pieces. We call that brittle. Compared with the metals, the non-metals have low density. Now, the density depends on the element. Some of the densities are so low that the substances are gases. They have very low melting and boiling points. That means that liquid bromine, for example, has a very low melting point, and the boiling point of chlorine is below room temperature. That's why chlorine is a gas. They do not conduct electricity or heat like metals do. That's why sometimes we can use the non-metals as insulators. And most of the time we use compounds as insulators, like plastic, for example. That is a very complicated compound, but in general, they don't conduct electricity. The exception for this is graphite. The pencil that you have in your mechanical pencils, or the regular pencils that you use, does conduct electricity, and we are going to see that when we cover bonding in the next chapter again. They are not sonorous. They do not produce that nice sound that a bell can produce, because they are non-metals. Also, they are soft in general, and that depends on the allotropic form. For example, in the case of a pencil, you can break it easier. But if you have diamond is the strongest or the hardest substance known so far. So diamond and graphite are allotropic forms of carbon, and but in general, all nonmetals are soft. This is a table that has like different properties of metals and nonmetals all together, so we can remember them. Some of the reactions with oxygens to form basic oxides, I didn't include those into this PowerPoint presentation, but you should know that they neutralize acids. And the reactions of nonmetals with oxygen are going to form acidic oxides in general. That acidic is because they are going to form acids with water, and those are going to neutralize the bases. The nonmetals do not react with acids. The metals in general react with acids, producing hydrogen gas, and we saw the exceptions.